Right, so we're going to get started on our last chapter. Can you believe it? We're already there. Anyway, this chapter is on cognition in language. So it's my hope that by the end of this chapter, you'll be able to distinguish between attentive and pre-attentive processes. You'll be able to provide examples of the phenomena that's related to attention, as well as looking at things in terms of change blindness. We'll be able to talk about what is known as attention deficit disorder, looking at how to use categorization in terms of how we think, be able to distinguish between type 1 and type 2 processing. You'll also be able to explain the advantages as well as disadvantages of maximizing and satisfying. You'll list the different eras of thinking. We'll talk about and look at how we lead to belief in conspiracy theories. That's going to be fun. Also, we'll talk about the basis of developing expertise and how and what experts will do that makes them experts. We'll also look at how to teach language to chimpanzees. At the end of this chapter, hopefully you'll be able to evaluate the explanations on how humans are specialized to be able to learn language, how we be able to distinguish between the types of languages as well as impairments after brain damage occurs. We'll talk about how children develop language and then also explain how role of our eye movements work when it comes to reading. So with that, we'll get started. First, let's take a look at Module 8.1, Attention and Categorization.
Cognition is just a fancy word for thinking and using knowledge. It's what your brain does when you solve a problem, make a decision, remember where you left your keys, or try to understand a new concept in class. Basically, cognition is your mind at work, processing information and connecting ideas, kind of like your brain's version of a Wi-Fi network, constantly transmitting data between thoughts. Now here's the interesting part. Cognitive psychologists, those curious scientists who study how we think, can't exactly see thinking happening. They can't peek inside your brain and watch your thoughts unfold in real time. Well, not without some serious MRI action. So instead, they look at speed and accuracy. How fast can you answer a question? How often do you get it right? These clues help them infer what's happening behind the scenes in your mind. It's like detective work, but instead of fingerprints, they track milliseconds and mistakes. And then there's this delightful twist called choice blindness. Ever make a decision and then completely forget or deny that it was your choice? Like insisting you never picked that awful movie on Netflix. That's choice blindness. The tendency for people to act as if they don't know what choice they made. Psychologists have found that sometimes we make decisions without really understanding why. And when someone asks us to explain, our brains quickly whip up a logical sounding story. We're natural born storytellers, even about our own choices. So, cognition isn't just about how we think. It's also about how we convince ourselves that we know why we think the way we do. Basically, cognition equals thinking and using knowledge. How it's studied equals speed and accuracy of responses. Choice blindness equals we often make choices first and explanations later. Our minds are clever, but sometimes a little too eager to sound confident. Now, what is attention? Think of attention as your mind's way of saying, hey, focus on this. It's important. Out of all the sounds, sights, and sensations happening around you, you can only tune into a few at once. You're constantly filtering, deciding, usually without realizing it, what to notice and what to ignore. That's why you might not hear your name being called if you're deep into a TikTok rabbit hole. Your mental spotlight is elsewhere. Attention helps you respond to and remember some things more than others. It's selective, and that's a good thing. Otherwise, your brain will be completely overloaded by all the information hitting your senses every second. Bottom-up processing. That's when the world grabs you. A bottom-up process happens when something in your environment forces you to pay attention. It's automatic and driven by stimuli, like a loud noise, flashing light, or someone yelling fire. Anything new, strange, or intense hijacks your focus before you even think about it. So, when a car alarm suddenly blares, that's your bottom-up attention saying, alert, something's happening. Top-down processing, when you take control. Now flip that idea. Top-down processing happens when you decide what to focus on, based on your goals, experience, or expectations. Let's say you're looking for your friend in a crowded room. You're using top-down attention to filter through faces and zero in on familiar features. You're basically telling your brain, this is what matters, ignore the rest. Your experience and expectations guide what you notice and how you interpret it. Brain power and focus. Here's the cool neuroscience part. What you focus on actually changes which parts of your brain light up. When you pay close attention to music, your auditory regions get more active. When you concentrate on a visual task, your visual cortex ramps up. Attention literally redirects your brain's energy. To recap, with attention, you're picking and choosing what to focus on and remember. As for bottom up, the world grabs you. Sudden noises, flashes, surprises. With top down, you choose what to focus on. Goals, expectations, experience. The brain's impact focuses on activating specific brain areas. Attention shakes your brain in real time. Just remember, your attention is both a reactive alarm system and a focused laser beam. The trick is learning when to let your environment guide you and when to take control of your own spotlight. Let's talk about pre-attentive and attentive processing. Basically, there are two gears your brain uses when taking in information. So first, there's pre-attentive processing, the brain on autopilot. Envision walking into a crowded room. Without even trying, you instantly notice things like bright colors, movement, or anything that stands out. Maybe someone wearing a neon jacket or a flashing exit sign. That's pre-attentive processing at work. This is your brain's autopilot mode. It happens fast and automatically before you even decide to pay attention. You don't have to think about what stands out. Your senses do the work for you. It's great for survival too. Our ancestors didn't need to analyze whether that rustling in the bushes was a tiger. Their brains just said, move. So remember, pre-attentive equals automatic, plus effortless and quick scan. Then we have attentive processing. That's when the brain is in manual mode. Now, when you actually stop and focus on something, like searching for your car keys on a messy table, you've switched into attentive processing. This is your intentional, effortful kind of attention. You're deliberately scanning, comparing, and filtering through information. It takes longer and uses more brain power because you're focusing on specific details instead of broad patterns. If pre-attentive processing is like glancing at a crowd, attentive processing is like spotting your best friend's face in that crowd. Okay, with attentive, it equals deliberate plus focused plus detail-oriented. To put it concisely, your brain first takes a quick snapshot of the world, pre-attentive, then decides what deserves a closer look, attentive. Together, they help you manage the endless flood of information around you without totally frying your circuits. All right, let's dive into how your brain juggles attention. or rather how it tries and sometimes fails to juggle it. First, there are myths about multitasking. You've probably heard people brag, "Oh, I'm great at multitasking." But here's the truth. Your brain isn't actually doing multiple things at once. It's just switching really fast between them. Every time you focus on one task, you take attention away from another. That means your total attention pie stays the same. You're just slicing it thinner. So when you're talking on the phone while driving, part of your brain is focused on the conversation. Wait, what did she just say? And part is focused on the road, red light or green. The result? You're less alert, slower to react, and more likely to miss something important, like that stop sign that definitely didn't just jump out of nowhere. Therefore, when you multitask, you're not being super efficient. You're making two things happen less well. Now, let's chat about when reading wins the battle. So here's a fun example of attention getting hijacked. It's called the Stroop effect. You've probably seen this before. A list of color words printed in mismatched colors, like red printed in blue ink, blue printed in green ink, green printed in red ink. The task is simple. Say the color of the ink, not the word itself. But your brain rebels. Because reading words is automatic, your mind keeps trying to read rather than focusing on the color. This shows how strong automatic processes can be. Even when you want to focus, your brain sometimes says, "Nah, I've got a shortcut for that." Then there's change blindness, the "wait, did that just change?" effect. Change blindness is another sneaky trick of attention. It's the failure to notice changes in a scene, even big ones, because your focus is somewhere else. For example, imagine watching a video where two people are talking, and in the middle of a camera cut, one person's shirt color changes, and you totally miss it. Your brain assumes the world stays stable, so it doesn't keep checking every detail unless something specifically draws your attention. Generally, your brain says, if it didn't seem important a second ago, it probably still isn't. So get into the nitty-gritty of it. Your attention is precious and limited. Multitasking drains it. Automatic habits hijack it, and sneaky changes can slip past it. So next time you're tempted to do it all at once, remember, even your brain prefers to focus on one thing at a time. Let's break down attention deficit disorder, ADD, and attention deficit hyperactivity disorder, ADHD, in a way that actually makes sense, without all the medical jargon. Attention deficit disorder is mostly about distraction and focus problems. People with ADD can seem like their minds are always somewhere else. They might start a project, get halfway through, and then poof, their attention drifts to something else entirely. ADD is often marked by easy distraction, like losing focus mid-conversation, impulsiveness, acting before thinking things through, moodiness, big emotional swings that seem to come out of nowhere, difficulty following through, lots of great ideas that don't always get finished. It's not laziness or lack of intelligence. It's that the brain's attention system is wired a bit differently. ADHD is basically ADD plus a burst of excessive energy. That means all the same focus and impulsivity challenges as ADD. However, with hyperactivity, can't sit still, always moving or fidgeting, restlessness, that I've got to do something feeling, even when it's quiet time, constant motion, it's like the mind and body are both racing. So, if ADD is like having a dozen browser tabs open in your mind, ADHD is like having all those tabs open and the music suddenly starts playing from 3 of them at once. People with ADHD and ADD often have trouble keeping their attention on things that don't feel interesting or rewarding. The brain's attention circuits rely on motivation and novelty. So tedious tasks, like paperwork or long lectures, can feel almost impossible to stick with. At the same time, switching between tasks can be tricky. It's not that they don't care, it's that their brains don't easily hit the focus or reset button. And here's the kicker. Not everyone's ADHD looks the same. Some people are mostly inattentive, more like classic ADD. Some are mainly hyperactive and impulsive, and others show a mix of both. Bottom line, ADD and ADHD aren't about not wanting to pay attention. They're about brains that struggle to regulate attention and energy. With support, structure, and understanding, people with ADD or ADHD can learn strategies that help them thrive. And sometimes that extra burst of creativity and energy becomes a real superpower.
Okay, so we're going to stop for a moment so that you can scan this QR code and we can get your attendance taken for October 27th, 2025. Don't forget.
There are two really interesting ways scientists study attention and self-control in people with attention deficit disorder, ADD, and attention deficit hyperactivity disorder, ADHD. The choice delay task and the stop signal task. Take a moment to contemplate. Someone tells you you can have one cookie right now, or if you wait 10 minutes, you can have 2 cookies. What do? That's the idea behind the choice delay task. It measures how well a person can delay gratification. People with ADD or ADHD often struggle with waiting for rewards because their brains are more tuned to what's immediate and exciting. The later reward feels too far away to be motivating. So in these tasks, researchers notice that people with ADHD are more likely to pick the smaller, sooner reward. Surprised. I'll take the 1 cookie now, rather than waiting for the bigger later one. It shows difficulty delaying gratification, a preference for immediate rewards, and trouble with long-term focus or planning. So above all, the choice delay task reveals how the reward system in the brain works. And for people with ADHD, that system tends to say, now is better than later. Let's talk about how our brains make sense of the world through categorizing. Suppose you're walking into a busy room, people chatting, music playing, snacks on the table. Your brain doesn't stop to analyze every single detail. That would take forever. Instead, it quickly sorts things into categories: people, music, and food. By categorizing, your brain saves time and energy. It's like having mental filing cabinets. Instead of relearning what a chair is every time you see one, your brain just pulls the info from the chair folder. Pretty efficient, right? But here's the twist. Not everything fits neatly into a single category. Some things have ambiguous definitions, which means they're a little fuzzy around the edges. For example, is a tomato a fruit or a vegetable? A hot dog, is it a sandwich? Cue the internet debate. These fuzzy cases make it harder for your brain to decide where to file them, which takes a little more thinking energy. So, categorizing helps your brain think faster and work smarter. Now, a prototype is your brain's best example or mental image of something in a category, your default. Think of it like this. When someone says bird, maybe you picture a robin or a sparrow, small with feathers and wings that fly. But what about an ostrich or a penguin? They're birds too, but they don't fit your prototype perfectly. That's why prototypes help us judge how well something fits a category. Depending on how closely something matches your prototype, you'll mentally label it as member of a category, a robin equals classic bird, non-member, a bat equals not a bird, and borderline case, such as a penguin or ostrich equals bird, but not quite the typical one. By categorizing, your brain simplifies a complex world. It's like taking a mental shortcut. But when something doesn't fit neatly, or when definitions are fuzzy, your brain has to work a bit harder to decide. Is this a member, a non-member, or something in between. Our brains are flexible. They can handle the gray areas, but they definitely prefer clear-cut answers. All right, let's take a peek inside your mental web of ideas. Your brain isn't a filing cabinet with neatly labeled folders. It's more like a giant web of connections where every thought is linked to other thoughts. When you think about one thing, your brain automatically lights up related ideas nearby, like a string of fairy lights turning on one after another. Whenever you think of something, say apple, your brain instantly links it to more specific examples like Granny Smith, Honeycrisp, caramel apple, more general categories such as fruit, food, snack. Related terms are orchard, pie, healthy, teacher. Yup, that apple for the teacher idea pops up too. That's how your brain keeps information organized and easy to access. It's always connecting the dots. Spreading activation occurs when one idea triggers a chain reaction of related ideas. Think of it like tossing a pebble into a pond. The first splash, your original thought, sends ripples outward, activating nearby concepts. For example, if I say dog, you might instantly think of leash, park, barking, fetch, or pet. All those ideas are connected in your mental web, and thinking about one wakes up the others. That's spreading activation, your brain's way of prepping related ideas so you can think faster and make associations. Now, priming is the practice of using one idea to nudge another into action. It's like giving your brain a friendly hint. If I show you the word nurse and then later ask you to fill in the blank, D blank blank TOR, your brain will probably shout doctor faster than if you hadn't seen nurse. That's because the concept of nurse primed the idea of doctor. So priming is basically warming up your brain's engine for a related idea. It gets your mental gears turning before you even realize it. To help you remember, your brain is a network. It's actually more than a filing cabinet. When one idea lights up, related ones follow. That's spreading activation. And when something gives your brain a little push toward a related thought, that's priming. So the next time you suddenly remember pizza when someone mentions Friday night, don't worry. It's just your brain doing its favorite thing, making connections. All right, it's time for a knowledge check. Why do you understand the word racket differently in a sentence about tennis than a sentence about noise? Okay, so how did you do? Well, the answer is that a sentence about tennis and a sentence about noise activate different sets of meanings by spreading activation. You adopt the meaning of racket that fits the set that was activated. Well, this ends today's lecture. Next time, we will pick up Module 8.2 and start discussing solving problems and making decisions. Be sure to scan the QR code for your attendance today.